look at systems of linear equations. You know that a system of linear equations can have exactly one solution, infinitely many solutions, or no solution. If the coefficient matrix A of a square system is invertible, then the system has a unique solution which can be found using an inverse matrix as follows. So systems of equations with unique solutions, if A is an invertible matrix, then the system of linear equations represented by A times x equals B has a unique solution given by x equals A inverse times B. So let's try that out into solving this system. So we're going to use an inverse matrix to solve the system. Now to write the inverse matrix, this is just A times x equals B. And so when we were setting this up, let's set up the matrix. So this is how you set up a system. You have 1, 1, so we're using these here, right, the coefficients. And then this is 0.06, 0.075, 0.095, 1, and then -2. And then you just do the coefficient matrix. Sorry, there's no dashes there. And then on this side, the x, that's just all of our variables. So this is x, y, and z. Okay, so that's what you're putting in place of the x here. Then on the right, those are the constants, 10,000, 730, and 0. So in order to find this, what we're going to do is you find the inverse of A using Gauss-Jordan elimination. Okay, and then so let's set this up first of all. So what this looks like from this point here is you do 1, 1, 1, 0.06, 0.075, 0.095, 1, oops, I got my 0 there, 0, and -2. And actually, sorry, on this side, what we want to do is we want to have the dashes, and then we put the identity matrix on this side, 1, 0, 0, 0, 1, 0, and 0, 0, 1. Right, so this is with the method that we used earlier in order to find the inverse. So this is our identity, this is A, and then when we do all that work, I'm going to give us the answer though, in this case. So when you do the work to find the identity is on this side, and then the answer in this case is 15, -200, -2, -21.5, 300, 3.5, 7.5, -100, and -1.5. Okay, so this is our A inverse. And so we're just going to use this inverse to solve here. So what we're using is we're going to do x equals A inverse B. So this is how this works. You take the inverse and you multiply it to B, and B is this information here. So we're going to put the A inverse, this, and then we're going to multiply it to B. So 15, -200, -2, -21.5, 300, 3.5, 7.5, -100, and -1.5. And then we're multiplying it to B, which is what we had earlier. So those constants, it was 10,000, 730, and 0. And then this is practice in multiplying again. So this is 15, right? So you do row by column. So just a good review, row by column. So we have one row, one column here. So this is going to be 15 times 10,000 plus -200 times 730, then minus 2 times 0. So I can really ignore that. 730. Oh, we rewrite that right there. And then -21.5 times 10,000 plus 300 times 730, and then minus 0. And then 7.5 times 10,000 plus -100 times 730, and then plus 0. Okay, so then if you plug that all in, the answer will be 4,000, 4,000, and 2,000 once you plug that all in a calculator. So then our ordered triplet is 4,000, 4,000, and 2,000. So that's just a different way to solve. We're using the inverse to solve for it. We could use Gauss-Jordan elimination in order to solve for this instead of using the identity, but it is asking to use the identity matrix to solve the system. Now you're going to try this one here. So go ahead and set it up, and you could use the Gauss-Jordan elimination, but what I'm going to do is I'm going to give you the inverse matrix. So the inverse matrix, A inverse, is -1, 1, 0, -1, 0, 1, and 6, -2, -3. So remembering you're using A times X equals B. Now we'll solve for X equals A inverse times B. So see if you can set it up. So set up this system here with matrices, and then see if you can solve it. All right, so this is the answer. You should have gotten 2, -1, and -2. And then, of course, if you wanted extra practice, you could also try to get the the inverse, A inverse. You can always get practice doing that. But I know in the homework that you're given for this time is they actually give you the identity, and you don't have to do the whole thing from the beginning. But hopefully you do know how to do it from the beginning. Start with this, set up your system just like we did here. Right, so you set this up first, right in this spot. Then you do the identity to the right of the coefficient matrix of A, and then do Gauss-Jordan elimination to solve for the identity, like we did in previous videos. Then you use that A inverse, and then multiply it to B, and then that's how you get the answer.